Here is another example of proving trig identities. You need to keep in mind that when you prove trig identities, that no two problems are going to work the same. You will learn tricks along the way that may be similar from problem to problem, but you're going to have to, come to terms to the fact that none of the problems will necessarily work the same way. On this problem, the left-hand side is obviously the more complicated side, so I will choose that side. The first thing that I will do is I will choose to turn things that are not sines and cosines into sines and cosines. So the first thing, sine squared of theta is already a sine function. Tangent of theta I can rewrite as sine of theta over cosine of theta. The denominator, cosine squared of theta is already a cosine function, but cotangent can be rewritten as cosine of theta over sine of theta. From this point, what I will do is I will find a common denominator in the numerator, and I will find a common denominator in the denominator. So in other words, if I write this fraction over 1 and this fraction over 1, we see that the LCD for the numerator is cosine of theta. The LCD for the denominator is sine of theta. And so what we'll do is we will get those common denominators both in the top and in the bottom. Sine squared of theta over 1 would need to be multiplied by cosine of theta over cosine of theta to achieve my common denominator. The second fraction I will keep as it is. The whole numerator is over cosine squared of theta over 1. That fraction needs to be multiplied by sine of theta over sine of theta to achieve its common denominator in the bottom. The second fraction already had its common denominator. Now, this being the case, I can go ahead and I can combine the whole numerator together, and I can combine the whole denominator together. This will look like this. I will have sine squared of theta multiplied by cosine of theta minus sine of theta, and then all of that is over cosine of theta. That is my numerator. That is now over cosine squared of theta times sine of theta minus cosine of theta. All that is over sine of theta. Now what I will do is something we had discussed earlier. If you have a fraction over a fraction, you keep the top fraction, you change division to multiplication, and then you flip the bottom fraction. So here's what this will look like. I will have sine squared of theta times cosine of theta minus sine theta all over cosine of theta. That's the fraction I kept. Then I need to multiply by the flip version of the denominator. That would be sine of theta on the top, and then cosine squared of theta times sine of theta minus cosine of theta in the denominator. Okay. At this point, what I can do is I can collect a couple of things together, and I can also maybe factor some things. Okay, the first thing I'm going to do is I'm going to factor a sine out of these terms. I see that both of those two terms share a sine, so I'll factor a sine out, and I'm left with cosine of theta minus 1. I'm going to keep its denominator as it was. And then over here on the second fraction, I'm going to keep the numerator as it was. And then I actually see that these two terms share a cosine function. So I can factor a cosine function out. Okay, in this case, I'm left with cosine of theta times sine of theta minus 1. Okay, I have a mistake. I need to correct my mistake. The mistake is in the numerator. I incorrectly factored the sign out. When I factor out one single sign, notice that I had sine squared. So I'm actually left with a sine times a cosine and then minus 1. Okay, now what do we see? We see a whole lot of different things. Okay, the first thing is there are actually two signs in the top that can be collected. This whole thing is being multiplied, so I can collect the signs that I have on the top and say there's 1 here multiplied by 1 there, so that'll give me sine squared. I will leave what I have in parentheses, sine of theta, cosine of theta minus 1. I can do something similar in the denominator. I have two cosines, they're being multiplied, and so that would be cosine squared of theta. Okay. The next term, in parentheses, y'all see a cosine multiplied by a sine. Well, at this point, what we can notice is that this term that's in parentheses on the top and the term that's in parentheses on the bottom is actually the same term. It doesn't make a difference that the sines and the cosines are multiplied out of order. That being the case, those two terms as a whole cancel out. That leaves us with sine squared of theta over cosine squared of theta. Well, sine over cosine we know is tangent. So sine squared of theta over cosine squared of theta is tangent squared of theta. And that was the result that we desired from up above. If we scroll back up to the top, we were wanting to show that the left-hand side was equal to tangent squared, and that is what we have done. This concludes this example of proving trig identities.